Assalamualaikum and good morning. My name is Balkis Sufia binti Abdul Razak Alim and I'm going to answer question number 1 and question number 4. So for the first question stated that what is differentiation and the technique of differentiation. So here are some of the technique of differentiation which we can find in this topic. So for the first one is the power rule. So basically power rule is a technique where we will multiply the power with the coefficient and minus the power with 1. So next we have the product rule. So for the formula for product rule is fx equal to vu prime plus uv prime. Lastly, in this topic we have quotient rule. That's all for question number 1.
So hi, Assalamualaikum. My name is Tengku Nur Kamilia binti Tengku Muhammad Rais and I will be presenting question number 2. For question number 2, the question asks to find dy over dx for the following functions. A is given 3x squared secant x plus 2. Our u is 3 squared and our v is secant x plus 2. To get u prime, we have to differentiate 3x squared. So our u prime will be equal to 6x. The next one is v. Our v is secant x plus 2. So to get v prime, we will have to differentiate one by one by using chain rule. So first we will have to differentiate secant x plus 2 and second one we have to differentiate in the parenthesis which is x plus 2. To differentiate secant x plus 2, we know that if we differentiate secant x, we will get secant x tan x. To apply that into this equation, we will get secant x plus 2 tan x plus 2. Next will be differentiate in the parenthesis which is x plus 2. So to differentiate x, we will have 1 because 1 will be times 1 to get 1 and then power of 1 will be minus 1 to get 0 and then we will have 1. To differentiate 2, we will get 0. So we'll have 1 here. And then 1 times secant x plus 2 tan x plus 2, we will get secant x plus 2 tan x plus 2. To differentiate the whole equation, we will be applying product rule. So product rule is dy over dx is equal to v times u prime plus u times v prime. We have our v is secant x plus 2 and then times u prime is 6x and then our u is 3x squared and times v prime is secant x plus 2 tan x plus 2 and then we will times everything here 6x times secant x plus 2 and 3x squared times secant x plus 2 tan x plus 2. So we'll get the final answer is 6x secant x plus 2 plus 3 squared secant x plus 2 tan x plus 2. For question 2b, it's given y equals to 4x plus 2 over cos x. So our u prime is 4. So for v, we have cos x. We know that when we differentiate cos x, we will get negative sin x. So we get our v prime will be negative sin x. To differentiate everything, we'll be using quotient rule, which is dy over dx is equal to vu prime minus uv prime over v squared. Our v is cos x times our u prime is 4 minus our u is 4x plus 2 and then our v prime is negative sin x and then we have cos x squared and then 4 times cos x we will get 4 cos x and then minus negative sin x times 4x plus 2 and then again over cos x squared. Here we have negative sign here which will become positive. So our final answer will be 4 cos x plus sin x times 4x plus 2 over cos x squared. So this is our final answer for question 2b.
Alright, hi everyone, my name is Wanasur Ashraf. Today I will be representing about topic of implicit differentiation. So, the question 3 is given here. You might see a little bit complicated. When we differentiate all of this, we actually can separate it to 3 parts. Here I have separated to the first part, second part, and also the third part. So the first one is we have to differentiate y ln 3x using product rules. I've shown you on the right side. We have to identify which one is v and which one is u, and there we can differentiate. On u prime, you might see a little bit confused, but actually we have to use this according to the formula of differentiative. So when we get this, we actually can ease it back according to the formula of product rules. The equation will be dy over dx times with ln 3x plus y times with 1 over 3x times 3. Here notice we can actually cancel out 3 and it will become y times 1 over x, and it will become this equation. Alright, now we settle for the first part. The second part we will have to differentiate e with the power of 2x plus 1. In this equation we have 2 parts to differentiate. The first part and also the second part. The first part we have to differentiate according to the formula of differentiative formula, and then the second part we can differentiate it normally. Here I show you how we differentiate 2x plus 1. Alright, settle for the second part. Now we move on to the third part. We have to differentiate tangent for y. We actually have 2 parts in this differentiate equation. Actually we have to differentiate the first part and then there will be second part. The first part is also we have to use this according to the formula of differentiative formula, which is y equals to tangent x. When we differentiate, it becomes secant power of 2 times x. So you can see here how I differentiate. Now the second part we have to differentiate y. I show you on the right side. When we differentiate y, it becomes dy over dx. Now we have settled all the parts. Now it's time for us to combine this dy over dx terms on the left side and the term without dy over dx on the right side. And the last part, we can easily solve this. Alright, I think that's all for my part. Thank you so much.
So lastly, I will answer for question number 4, which is stated that fx equal to square root 4 80.99 minus 2 over square root 80.99, and we need to give the answer into 3 decimal points. So first, when we see this kind of question, we need to identify 3 terms first, which is x, x naught, and delta x. So as we can see in this question, x is 80.99, x naught is 81, and to find delta x, we need to minus x with x naught. So we will get negative 0.01. And then we need to replace 80.99 with x, and then we will get square root 4x minus 2 over square root x. And then the next step is we need to change into power fraction, and we will get x to the power of 1 over 4 minus 2x to the power of negative 1 over 2. And next we will differentiate the function, and then we need to sub in the information we will get into the formula, which is f x naught plus delta x equal to f x naught plus f prime delta x naught delta x. So then for this function we will get 25 over 9, and for this one we will get 31 over 2916 and multiply it with negative 0.01, and then we will get the answer for this question is 2.778, and that is the final answer in 3 decimal points.